Good morning, everyone. Welcome to the class of CE261 Fluid Mechanics. In our last class, we discussed this problem, the solution of this problem uh, that involves the pressure, total pressure due to mixture of these two liquids, oil and water. Now we'll start today from here, absolute and gauge pressure. Now, if we consider this, let's say Earth, right? This is the Earth. And we have an atmosphere surrounding our Earth, right? We have an atmosphere surrounding our Earth, and it extends up to certain kilometer starting from the surface, right? Right.
Yes, sir.
So this is actually what? This is actually gas. Mm. So if this is gas, that means this is fluid. That means we are actually fully submerged in a fluid, right? We human beings are fully submerged in a fluid. Am I right or wrong?
Yes, sir.
Right, sir.
Yes, sir.
But we don't feel it, by the way. Hmm. When you go to the space, there you do not have any air. That means you're not submerged with fluid anymore. But here you are fully submerged. Now look at this. If I tell you, if this person is fully submerged in a fluid, then by the virtue or property of fluid, there will be a pressure acting upon this person exerted by the fluid, right? By the gas.
Yes, sir.
And it starts from the top surface of the atmosphere, or, and this starts, so you start counting h from top all the way up to this. So the pressure at this point will be what, guys? Gamma air into h, right?
Yes, sir.
Yes, sir.
Fine. Now, although this h can be very high, gamma a is very small. The unit weight of gas is very small. That's why this p from the air is very small. Okay,
Yes, sir.
let's say at this point here, you have a pressure exerted by what? The gas. That means the air, right? And we're telling that this is what? This PA equals to gamma A into HA. And HA starts from the top of the atmospheric surface all the way up to this. So this is actually HA, gamma A into HA. This is the pressure at this point. Now, this scenario is kind of similar to this scenario. Now, oil, in case of oil, there is air, and now this is water, right? So this is, you can think like, okay, this is a fluid, which is a gas, all the way up to this, starting from this, all the way up to this. This is a fluid, I'm sorry, this is a fluid, and this is another fluid, right? Clear?
Yes, sir. Yes, sir.
Now, tell me what would be the pressure at this point? The pressure at this point due to water, by the way, due to water, will be PW equals to gamma W into HW, where this is HW. Now tell me, what is the total pressure here at this point? The total pressure at this point is PA plus PW, right?
Yes, sir. Yes, sir.
Yes, sir.
Clear? This is the total pressure, P total. Okay. Now, in fluid mechanics, in actually in hydrology, while mainly we are dealing with water pressure, we neglect this PA. Why? Because this PA is very small. Are you following me? Very
Yes, sir.
small.
Yes, sir.
Why? Because gamma A is very small. Density of air is very small. But when you do some special kinds of experiment, like uh, which involves very small sensitivity of pressure, then you may have to consider this. Okay. So in that case, you consider PA, and to measure the pressure at any point, you need to take both PA plus PW. So since we are taking overall pressure, all the pressures together, that's why we call it absolute pressure, P absolute, right? We call it P absolute pressure. Okay.
Yes, sir.
However, as I told you, that in case of hydrology, we usually do not incorporate PA. That means we consider this PA as the reference. That means zero. Here, no pressure. Instead of pressure PA, we consider there is no pressure. Okay. And we only consider the pressure, that is PW. So we call this gauge pressure. Why? Because gauge is a meter that measures the pressure without considering the atmospheric pressure. So we call it P gauge, gauge pressure. That means you can see from here that P absolute, that means this one, is equals to the P gauge plus P atmospheric pressure. PA means P atmospheric. Clear?
Yes, sir.
This pressure from the atmosphere, we call it PATM, P atmosphere. Okay. So P absolute equals to P atmosphere plus P gauge. Now, so we use only the gauge pressure in problems dealing with liquid, because comparatively the air or atmospheric pressure is negligible. Now, if you see the graph, let's say this is the XY graph. Okay, this is X and this is Y. So when this is zero, so when we measure the absolute pressure, we have to measure all the way starting from zero, right? So this is, we have to measure the absolute pressure from absolute zero, absolute pressure P absolute, and this reference, this axis is absolute zero. But when we are dealing with gauge pressure, let's say atmospheric pressure is let's say atmospheric pressure is here. This is P atmosphere, and this is P gauge. So P absolute will be P gauge plus P atmosphere, right?
Yes, sir.
But when you consider the gauge pressure, then you don't start from here. You start from here, right? So this is the gauge pressure. GAG. This is the gauge pressure. So we call it, usually atmospheric pressure is this Pascal. Okay. Usually atmospheric pressure. You see this. This is atmospheric pressure. So atmospheric pressure is this, and this is measured at mean sea level. At mean sea level. Hmm? So this is your absolute. This is your atmospheric pressure level. So this is your actually a virtual zero. Virtual zero when you measure gauge pressure, right? For this gauge pressure, this is zero, right? This is virtual
Yes,
zero,
sir.
and this is the absolute zero. Okay. Now, sometimes your pressure when you are measuring gauge pressure, this is your zero line. Now, if you are here, then what will be the gauge pressure? Remember, for gauge pressure, this is zero line for gauge pressure, virtual zero. This is virtual zero. Now, when you are measuring gauge pressure and you see you are here, that means you are below zero, right?
Yes, sir.
Below zero means what? Negative or positive?
Negative, sir.
Negative. So if you are here, then that means here, or I mean below this line, that means this is negative pressure. I mean, we call it vacuum. We call it vacuum. Okay. So gauge pressure can be negative, but absolute pressure can never be negative. Okay, clear?
Yes, sir.
Now to measure the pressure, we use different types of meters. One of the uh, very widely used meter is manometer. Okay, so manometers are devices that employ liquid column, liquid column to determine pressure or difference in pressure. Manometers are of two types. Number one, simple manometer, usually called a piezometer. Okay, a simple manometer is called a piezometer, which measures the pressure in a pipe or vessel of liquid. Are you following me, guys?
Yes, sir.
Yes, sir.
Now let's see what is simple manometer. This is a pipe. This is a pipe, and water is flowing through the pipe. Okay. Now, why the water is flowing? Because the water is under pressure. Remember, the water is under pressure, and this water is exerting pressure on the surface of the what? Pipe wall, right? Exerting pressure on the surface of the pipe wall. This is velocity here, and pressure. And this pressure is perpendicular, as we learned so far, that this pressure is in perpendicular direction to the surface of the pipe, right?
Yes, sir.
Fine. So this is pressure. Now, what's happening? Remember, what's happening? That this pressure is trying to is actually exerting force on the wall of the pipe. Okay. Now, what happens if you inject inject a tube here? If you inject a tube here, then what happens? What will happen, guys? Due to this force or pressure, the water will rise, right?
Yes, sir.
Yes, sir.
Okay. How much the water will rise? Higher is the pressure, higher is the height of the water column, right?
Yes, sir. Yes, sir. Yes, sir.
This is actually H, and you can see this H is related with this P. That means P equals to gamma H here. Okay.
Yes, sir.
So basically, what is happening that this pressure and the pressure due to the height of the weight of the column, water column, they are actually balancing each other. That's why this is stable. So P equals to gamma H. So this simple device, this is called piezometer. So, or simple manometer. Using this piezometer, you can determine the pressure that is acting upon the wall of the pipe due to this fluid. Did I make it clear?
Yes, sir.
So simple manometer P equals to gamma H. It is usual to express the pressure in equivalent head of water. If the specific gravity of the liquid is S, the pressure at A. Oh, by the way, what is this? This is just nothing. You are looking from here, guys. This is your eye, and you are looking from here. Okay? Let's say you're looking from here. Then what did you see? You'll see a circle like this and this. This is the piezometer, okay?
Yes, sir.
Okay. Now it is usual to express the pressure in equivalent head of water if there is specific. That means that this liquid can be water, this can be oil, or any other types of liquids, right? So of course, this H will vary based on this gamma. For example, the pressure here is 10 Pascal or Newton per meter square. Okay, 10 Pascal. So you can say if gamma W of water is 9.81, then let's say, let's not write that way. Let's say gamma of any liquid here, liquid 1, gamma 1 and H1, right? So gamma 1 is, let's say, 10. Then what will be H1?
1, sir.
1,
1.
sir.
Fine. So this 10 Pascal pressure is will be represented by 1 meter height of this liquid 1. Now, if you have a heavier, if you have a lighter liquid, okay, and which is gamma 2, let's say, then H2 will also be changed. Let's say gamma 2 is 5. Then what will be H2?
2.5.
2, sir.
2. So interesting, look at this now. That the same pressure, liquid 1 needed 1 meter height, but liquid 2 needed 2 meter height. Why? Because this is lighter and this is heavier. So only 1 meter is enough to make 10 Pascal pressure, right?
Yes, sir. Yes, sir.
Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
So when you are representing the pressure with the height of a particular liquid, you must mention what is the liquid. Okay, because H will vary from one liquid to another. Now, usually water is a universal kind of liquid, so we use, it's easier to express pressure in terms of height of water. In terms of height of water. So you have to write what? P by gamma W, right? Clear?
Yes, sir.
Okay. Now, if you have represented the height of the pressure in terms of height of any liquid, let's say liquid, then what is the relationship between this and this? What is the relationship? Let's see. Let's see at this point A. At this point A, this is a liquid, let's say. At this point A, what is the pressure? PA equals to gamma W HW. And this is water, by the way. This is water. So gamma W HW. So at point A, small is capital A. So at point A, the pressure is gamma W HW, which can be also written as gamma 0 H0, right?
Yes, sir.
Fine. So from here, you can write H0 equals to this. Let me write it down for you. So PA, pressure at any point, equals to, as I already wrote this here. Okay, gamma 1 H1 equals to gamma 2 H2 equal to gamma 3 H3. So let's say gamma water H water equals to gamma any other types of liquid, gamma 0 H0. So from there, you can write H0 equals gamma W divided by uh, from here you can write this hw equals to gamma O by gamma W into HO. Can I write this? Can you write this?
Yes, sir.
Now this is what?
Specific gravity.
Specific gravity, exactly, of this oil or liquid, whatever you say. Okay, so we got this. The relationship between height of water and height of any other type of liquid is this. Remember this. This is very important. We need this. Simple. So if you want to convert the height of liquid to water, then you have to multiply the specific gravity of that liquid with this. Then you'll get height of water. Clear?
Yes, sir.
So
Yes, sir.
gamma W equals to HO into S. Or you can write HA equal to HS, where H equals to HO, S equals to S. And okay. Now, a double column or a U-tube manometer. What is this? This is simple manometer. What is U-tube manometer? U shape, because this is U shape. Look at this. This is U shape, right? That's why this is U-tube manometer. Okay. Now,
Yes,
why
sir.
are you are using U-tube manometer? Sometimes uh, it's clear that the piezometer will not work for negative gauge pressure. It is obvious that the piezometer will not work for the negative gauge pressure. This one. Would it work for the, they're talking about this one actually, this one. This is not valid for negative gauge pressure. When you have negative pressure, then simple manometer cannot give you the reading, because it cannot go, it cannot plunge inside the tube or pipe. So this is not suitable. That's why. Right. Clear? Are you following me, guys?
Sir,
Yes, sir.
I cannot hear clearly, sir.
Okay. So no problem. I can repeat it. I mean, when you have a negative pressure, then this doesn't work, because atmospheric negative pressure means your pressure here is less than the atmospheric pressure. So atmospheric pressure is now stronger. So that will plunge the water inside of it. And that will be difficult for you to measure the water pressure. So manometer, simple manometer is not suitable in case of measuring negative pressure. That's why we are moving towards U-tube manometer, these types of manometers. That's one case. Another case is if your pressure is very large here, then in case of simple manometer, you'll see that this will rise all the way up, right?
Yes, sir.
Yes, sir.
This is inconvenient. That problem also gets resolved when you use this piezometer, because as you can see, we are balancing the pressure here. This and is acting here, this is acting here. So they are actually balancing each other. So these cases of extreme low pressure and extreme high pressure can be resolved here. This U-tube manometer can give you reading in case of this. And what is happening here? Here you are using a mixture of liquid. Here you're using a mixture of liquid. This one is, let's say, water, and this black one, let's say this is mercury. Okay. Anyway, so now how to interpret or calculate the pressure using the U-tube manometer. Let's say you have to know some rules that is described here. Okay. So So what they're telling you here is this. Um, let's say for this one, you want to know the pressure. You want to know the pressure at this point. Okay. Let's consider this one, not that one. Yeah, because they are using this figure. So let's consider this figure. Okay. And you wanna know the pressure at the center of this pipe, PA. What will be that? So let's determine this. First of all, this is PA. You need to write PA. Remember that summation, the law of equilibrium, summation of fx, summation of fy equal to 0.
Yes, sir.
We are just applying that one. Here the pressure PA, fine. Now you have to move in this direction. You have to move in this direction. You have to move in this direction. Okay. So you were here at this point, PA. We have written PA, fine. PA. Then now we'll go downward, right? We'll
Yes,
go
sir.
downward. So downward, if you go downward, you have to write positive. Always remember, when you go downward, this has to be positive. Clear?
Yes, sir. Yes, sir.
Yes, sir.
How far you are going? You are going from there to there. What is this height, guys? From there to there?
H2.
H2, vertical height, H2. So H2. And we are using height to represent pressure, right? You're using height to
Yes,
represent
sir.
pressure. That's
Yes,
why
sir.
instead of writing PA, you write HA here. That is also pressure, but we have expressed it in terms of height of liquid. So this is HA here plus H2. Fine. Now you are here, right? HA plus H2. You are here, right?
Yes, sir.
Yes, sir. Yes, sir.
Now you go up to this. And let's say this is Y. So in which direction you have gone, guys? Downward, right?
Yes, sir. Yes, sir.
Downward means positive.
Positive.
Y. Now where are you? You are here at this point. Okay. Now you have to go where? You have to go upward now, right?
Yes, sir.
You have to go upward. And how much up you have gone?
Minus 1.
Y, right? But this is upward, so this has to be negative. Clear?
Yes, sir. Yes, sir.
So Y. Now where are you guys? Here, right? Right?
Yes, sir.
Fine. So how far you have to go? You have to go all the way up to here. Go there. This is upward, right?
Yes, sir. Yes, sir.
So
Minus.
this is negative again. This is negative again for upward. And this is H1. Now look at this. This is in equilibrium. Are anything moving here?
No, sir.
Yes, sir.
This is equals, they are actually in balanced condition, equilibrium, so that has to be equals to 0. Done. Finish. Now y cancels out. You have a scale through which you can measure h2, right? You have a scale
Yes, sir.
through which you can measure h2. So h2, you know this, and you can also measure h1, which was unknown. Ha is unknown, so you just calculate ha. That's it. Clear?
Yes, sir.
So remember this. Okay. Now you should look at this. What's happening here? When you have a U-turn like this, then always this y and y will cancel out, right?
Yes, sir.
So as a shortcut, you may skip this part because we know that this will cancel out because this is the same liquid. Once you are going downward or you are going upward, this is the same liquid. The red and green, they are same liquid, by the way. Okay.
Yes, sir.
And you have only two liquids here. You have only two liquids here. What are they? This is one type of liquid, and this is another type of liquid. Okay. And I have shown this color to show the direction. Okay. That's it. Any question?
No, sir.
No, sir.
Now, if you understand this, then you know everything to solve these problems. Okay. Let's say this one. Before going to the problem, I just want to finish it. This one. We were here, simple manometer, then differential manometer. What is differential manometer? Differential manometer means, when you have two pipes and you want to know the difference between the pressure between the two pipes, then you use a manometer, you use a U-tube manometer to know the pressure difference. That's it. Okay. Like this one. Look, see, you have a tube here, you have a pipe here, you have a pipe here. So you're using a manometer to know the difference between the pressure in these 2 points, PA minus PB. Clear? This is called
Yes.
differential manometer. Okay. So let's start from here. U-tube manometer. There you have a single pipe, and we want to know what is the pressure at this point, HI. So this is simple. HI. You start from here. HI. Then you go all the way up to this. This is what, guys? 5. You have gone down one, right? So this will be positive or negative?
Sir, positive.
Positive, sir.
Positive. 5. This is 5 centimeter. Let's say this is 0.05 in meter into what is this liquid down. By the way, first of all, you need to know one thing. That's it. When you are mixing liquids, this is one type of liquid. This is another type of liquid, right?
Yes, sir.
Yes, sir.
Okay. So you have to remember that you can add apple with apple. You cannot add apple with an orange. So the height of the liquid of this one cannot be added to the height of the liquid of this one. So we need to bring them all in a single scale, a same scale, and that's the water scale, water. So let's say we are bringing all of them in water scale. So what would happen? HI. Then this is in terms of water. Similarly, plus H. Let's say this is 1, H1. This is H1. This is also in terms of what? Water, right? Are you following
Yes,
me?
sir.
Yes, sir. Yes, sir.
And other. But this H1 is not a and water, right? So what you have to do? You have to go to that equation. Look at this.
Yes.
If this is other than water, then you have to multiply it with the S to get it in terms of water. Okay? Okay? So since this is not water, so you have to multiply it with its specific gravity. Then you will get this in terms of water, because this is in terms of water. Everything will be in terms of water. Then you can add them. Clear? Fine.
Yes, sir.
So let's start again. And whatever I have discussed so far here, that is also applicable here. Okay, this is HaH2 YH1. Hmm. So if any liquid is other than water, then you have to multiply it with S. Hmm. Let's say I think this is the liquid which is not water. So you have to multiply H1 with S1. Hmm. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
So now it's easy. So HI, you're going downward, so plus 0.05 into S. We don't know S. Let's say this is S1, and then this is cancels out, so we don't consider this. We start from here. We're going upward from here, and this is negative 0.15 into S2 equals to 0. Simple. What is S1,
One
guys?
second.
A YouTube manometer containing mercury has its right limb. So this black one is mercury open to the atmosphere, and the left limb is full of water. Oh, this is water. So this will be 1, right? And what is the specific gravity of mercury? This black portion, this is actually 13.6. Okay,
Yes, sir.
13.6. Fine. So the lieutenant got find the pressure water in the pipe. That means here above the atmosphere for the manometer. Okay, so this is done. We are done. H1 equals Hi equals to what? Tell me, guys. What is Hi? First, do this and take a negative. You'll get the value. Tell me the value, please. Tell me the value, please.
So 1.99
So 1.99. What? You have put everything in terms of
meters, sir.
meter. 1.99 meter of what?
Water.
Which liquid? You have put everything in terms of water. This is in terms of water. This is in terms of water. So of water. Now, since you know the height, the pressure in terms of height of that liquid, you also know the liquid, then you can always calculate PA is what? PA equals to gamma W into H W. Gamma W equals to 9.81 and HW equals to 1.99. 9.81 what? Kilonewton per meter cube, right? Huh?
Yes, sir.
Kilonewton per, and this is meter. So what will be the unit here?
Newton per meter.
Kilonewton
Is square.
per meter square. Exactly. Kilonewton per meter square. And if you multiply this is 19.52. Okay. That's it. Similarly, this is the same kind of problem here. A YouTube nanometer containing mercury, whatever it is. Let's see this same thing. Hi. Then you're going downward. How much? 2 centimeters. So 0.02. We don't know what is the liquid. So S1. So then this part. This part is what? Again, you're going downward. So plus 0.05 into. We don't know what is the liquid. So S2. Then you are here. So this cancels out. Same Y. This is also Y. So they cancels out. Now you're here. You have to. Is there anything else? No, then there's nothing else, guys. This is done. There's no other liquid. So equals to 0. Now what is S1? S1 is S1 is water, maybe, right? Water, yeah. S1 is water. So this is 1. What is S2? S2 is mercury. 13.6. Done. So Hi will be, look, what is this? Minus 0.7 meters. That means the pressure is what?
Negative, sir.
Vacuum, sir.
Negative. Vacuum. If you write vacuum, you don't need to write negative. If you do not write vacuum, you have to tell negative. Anyway, so PW1 equal to gamma into H1. Similarly, minus 9.81 into 0.7. Negative. Negative. Okay. Differential manometer. Same thing. There is nothing new. What happened that in this case, what you have done that this is open to atmosphere, right? This is open to atmosphere, right?
Yes,
Yes,
sir.
sir.
Here.
Yes, sir.
So atmospheric pressure, you're dealing with gauge pressure. So in case of gauge pressure, atmospheric pressure is taken as 0, right?
Yes, sir.
Like this in this case. There's nothing else here. This is open to atmosphere in this point. So you have written equals to 0. Now, if you have a pressure instead of open to the atmosphere, this is connected to another pipe where there is pressure. So in that case, this will be equal to not 0. This will be equal to that pressure. That's it. Okay, simple. Let's say let's solve this problem, then it will be easier for us to visualize. Let's see this one. So this is a differential manometer. Hmm. This is one pipe, this is another pipe, A and B. You need to know what is the difference in pressure between pipe A and pipe B. Okay, this is maybe a liquid. This is oil. Okay, this is oil. The specific gravity is zero 0.8, and this is mercury. The black one is the mercury, the white one is the oil, and this is same oil. Okay, now same formula or method, HA, HA. Then we are going upward, positive or negative?
Negative.
Negative, sir.
Negative H1, multiplied by S1. You are here, you have to go all the way up to this. This is H2. You have gone upward, so negative, multiplied by S2. Now you are here, so this and this cancels out. So you are here. Now you are going downward. It is H3. Downward means
Positive.
positive. So H3 into, remember that this liquid and this liquid is similar. So you have to write S1. This and this liquid is similar. This H1 and H3 liquid is similar. So S1, S1. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now equals to is what? Equals to
Sir, HB.
0. No.
No, sir.
HB, right? HB. Done. Now you know H1, that's given 0.3. This is 0.3. Then what is S1, guys? S1 is 0.8. Then H2, what is H2? 20 centimeter. So this is 0.2. And then S2, what is S2, guys? S2 is mercury, right? 13.6. Then H3 is what, guys? 60 centimeter. And S1 is again, 0.8. So can someone please tell me what's the value of this part? Only this part, including negative. Okay, just exclude the negative now. What's the value, guys?
Sir, minus 2.48.
Did everyone get the same value?
Yes, sir.
Minus
2.48.
2.48. Are you sure? Check this again. All the people got the same value.
আর আপনি এখানে যেটা করা আছে এখানে 1 ধরে করা আছে আর আমরা যেটা করেছি স্যার 0.8 ধরে করা আছে
Let me check. 1, right?
স্যার এখানে
Okay, let
বলা
me
হচ্ছে
check. Let me check. Barometric pressure. Oh, okay, I got it. I got it. So they are telling that liquid A and B are water and manometer. Okay, sorry. So liquid A will be water, right? So this is water. So this will also be water. 1. and S2 is actually 0.8. Okay, S2 equals to 0.8. Now tell me the value, please.
Sir, 0.14.
0.14. Negative, right? Hmm?
Yes, sir.
So negative, negative, it will be positive, equals to HB. So you can write HA minus HB equals to minus 0.14. That means that HB is larger than HA. The pressure at B is higher than pressure at A. HA minus HB equals to minus 1.14 meter of water. Now what they have asked us to do, determine PA minus PB. Determine PA minus PB. So this is simple. PA minus PB is this. Um, you know HA minus HB. So PA minus PB equals to gamma A, gamma W into HA minus gamma W into HB. So gamma W HA minus HB. This is actually gamma W HA minus HB is what, guys? Minus 0.14, right? So multiply it with 9.81 and tell me the value, please.
Sir, minus 1.3734.
1.37. This is Pascal. Okay, kilopascal. I'm sorry, this is kilopascal because 9.81 kilonewton. Clear?
Yes, sir.
So A is done. Now in B, what they have asked is if PB is this, PB is given now. PB now is given, and the barometric pressure is barometric pressure means the atmospheric pressure is 76 meter of mercury. Find the pressure at A in meter of absolute water absolute. So first of all, simple thing. They have we know PA minus PB, or we know HA minus HB. They have given PB. Now they are asking what will be PA. That's it. Okay, but they're asking PA not in terms of pressure. They're asking in terms of what? Height of water. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Also, they're asking it in absolute value, not in gauge pressure. They're asking it in absolute pressure. So that's okay, no problem. So first of all, let's they have given PB. Let's convert it to HB. H equals to P by gamma. So PB by gamma. PB is what? PB is given 50. So you just put 50 here. And then what is gamma? Gamma is 9.81. This is kilonewton per meter square, and this is kilonewton per meter cube. So kilo cancels out, you get a meter of water. Now this is what? This is gauge pressure, right? This is what? Hmm?
Yes, sir.
Gauge
Gauge
pressure.
pressure.
Gauge pressure.
Now absolute pressure is what? H absolute, you know, is equals H gauge plus H atmospheric. The H gauge pressure is this 5.097. Hmm. Now H atmospheric is given in terms of what? In terms of mercury. But this is in terms of water. So if you want to bring it in terms of water, then you have to write this. H mercury multiplied by S mercury. Right?
Yes, sir.
Yes, sir.
That's what they have done. That H mercury is what? 76 centimeter. That means 0.76 meter. And S mercury is 13.6. So this is 13.6. And this is 5.097. This is 5.097 plus this. So you got HB absolute in terms of water is this. Clear?
Yes, sir.
Clear. Now we have done it. So you know HM minus HB. So if you know HB, if you put the value here, you get HA. That's it. Clear?
Yes,
That's
sir.
exactly what they have done. Done. Any question on this, guys?
স্যার আমাদের কি স্পেসিফিক গ্র্যাভিটি কি স্যার কোশ্চেনে দেওয়া থাকবে?
If this is mercury, right, then it's better to memorize it. If it is anything other than mercury, then it will be given. But for mercury and water, you should remember it. Water, you know, this is 1, and mercury, you know, this is what? 13.6. That's it. If this is any other liquid, then that will be given. Okay?
ওকে স্যার।
Any question, guys? No question. Okay, then thank you very much. Have a good one and stay safe.